Hi, my name is Tom McSweeney, and in this video I'm going to walk you through the structure of a typical DataNexus application deployment repository. We have a number of these repositories that we've created for deployment of all of the various components that make up the DataNexus platform, but hopefully in walking you through the structure of one of them, you'll be able to better understand the rest. For purposes of this video, I'm going to focus on the Zookeeper repository. So the first step in the process is going to be to go ahead and clone down that Zookeeper repository to my local system. Once I have this cloned down, I can go ahead and open it up in my favorite editor. For purposes of this video, I'm going to go ahead and use the Atom IDE because it's relatively easy to follow. And I'm going to drag that window back over onto this desktop and make it a little bit bigger so that it's a little easier to walk through. You can see that the repository itself is a fairly standard structure for an Ansible playbook type of a repository in an open source project. There's a README at the top level that walks you through the git clone operation that I just showed you in terms of installing the repository locally. And then it walks you through at a high level how to use the role in this repository and its associated playbook to deploy Zookeeper local, either in an AWS environment or in an OSP environment. In addition, there's a license file at this top level that explains the open source license that this was released under. It's an APL v2 license, and a contributing markdown file that gives you some basic rules for contributing to this repository if you're interested in doing so. It is an open source project, and we do welcome contributions from third parties. At a high level, most of these projects have a provision-application.yaml where the application is something like Zookeeper or Kafka or Cassandra. This is the playbook that's actually used to run or to deploy Zookeeper to the target nodes. In addition, there's a docs subdirectory at this top level, and inside of there are a series of markdown files that all walk you through the process of things like, the deployment scenarios that are supported by this playbook, how to use dynamic or static inventory to control the playbook run, how you can customize the deployment, and the supported configuration parameters that this playbook allows. And these four docs are typically available in our application deployment repositories. There may be additional documents to explain additional features or capabilities of specific application deployments, but these four typically always appear in our application deployment repositories. In addition, there's an Ansible config file at the top level in this repository, and it's fairly simple. It sets up a roles path that includes the roles subdirectory of this repository and its root directory. So Zookeeper itself is a role. You can see that there's a tasks subdirectory here and a templates subdirectory here. So there is a Zookeeper role that invokes the main.yaml here within the tasks subdirectory. And this main.yaml actually walks through the process of deploying Zookeeper. We'll go through that in a future video. The roles subdirectory has a set of roles that are generic and appear in most of our application deployment repositories. There's an AWS role that's used to create new virtual machines in an AWS environment. There's a corresponding OSP role that's used to create virtual machines in an OpenStack or a RHEL OSP environment. There is a build app host groups role that's used to actually dynamically build the application host groups from a matching set of nodes in a cloud environment. And there's an HTTP proxy role that's used to set up an HTTP proxy for the playbook run in those situations where you might be running this playbook from behind an HTTP proxy in an enterprise environment. In addition, there's a role here that is used to initialize the play. It does a number of different things, including setting up the various network associated parameters. And it's called in most of the plays that we run in our playbooks. And there's a pre-flight role that's used either when you create virtual machines in an AWS environment or an OSP environment to actually configure those new nodes so that they're on the appropriate networks, they have the appropriate data volumes attached to them. Those data volumes have the appropriate file system built on them. All that happens in this pre-flight. So you'll create virtual machines with either an AWS or an OSP role call, and then you will use the pre-flight role to finish the configuration of those new nodes before you proceed with the rest of the playbook. So that's the basic layout of the project. There are tasks, as I said. There's also a templates folder that may appear at this top level for any templates that are used in the Zookeeper role. And there may be a files subdirectory as well that's used by the Zookeeper role when there's external files that need to be referenced. The rest of this this discussion is associated with how we configure the playbook run. And there's actually two files that are used to do that. There's an application vars file here under the vars subdirectory in all of our playbooks. You can see here it's zookeeper.yaml. And inside of this file, we define the parameters that are typically used and probably won't change much from one playbook run to the other. All of our vars files include an application, or at least most of them do. That application is set typically to the same name as the repository, so Zookeeper, Kafka, Cassandra. And this is actually going to be used as a tag for the virtual machines that are being created, to tag them as Zookeeper nodes or as Kafka nodes or as Cassandra nodes. In addition to that application, we define a number of fairly standard parameters that are all prefixed by Zookeeper. You can see that there's a Zookeeper dir here. That's the directory that Zookeeper is going to be installed into on the target machines. Basically, we're going to bring down the Zookeeper distribution, which is a gzip tar file from the main Apache website, and we're going to unpack it into this folder. This folder will be created on the system, and we'll unpack it there. There's also a Zookeeper data directory, and this is an associated data volume that's mounted during the pre-flight role that I mentioned earlier. This is going to place Zookeeper's state into a /data/Zookeeper subdirectory on the target systems. For Zookeeper, there's also a log directory, and this is where Zookeeper's logs will be placed under /data/log. In most of our systems, we have a package list, again prefixed by the application. That package list is the list of packages that must be installed for the Zookeeper service to start. So you can see here we're installing the OpenJDK packages. For most of our playbooks, these OpenJDK packages are installed because we're installing things that depend on Java. There are some where this package list might be empty or might include things like the EPEL packages for installing additional packages that only appear in the EPEL repository. Most of our playbooks will use an application user and group that's, again, typically set to the application name. This user will be created under this group as part of the playbook run, and this is the user that will be used to start the associated service. So the service will run under the Zookeeper username rather than running under, say, root. Most of our repositories have some sort of version associated with them. You can see that in this example, we're going to install version 3.4.11 of Zookeeper. And you can see that this is actually used to dynamically build the URL that should be used to download Zookeeper from the main Apache distribution site. There is an option in most of our playbooks to upload these files as well from the Ansible system, but I'm not going to go into that here. In addition, when we're deploying new virtual machines to a cloud environment, we're going to go ahead and create some private keys or public-private key pairs that should be used to access those systems during the playbook run. And those will be stored in this private key path. By default, the private key path will be set to the playbook directory. So in this case, /temp/zookeeper. And any private keys that are created during the AWS or OSP run, the run of that role, will be stored in that directory. You can easily change this using a configuration file. I'll show you that an example of that in a little bit. And a lot of times you might want to change this to be a more central location where all of your keys will be stored from all of your playbooks, or at least all of your keys for a given project, or even a given project and domain. And again, I'll get into those in a moment. In addition to these basic parameters, which appear in a lot of our playbooks, there are Zookeeper specific parameters. So in this case, I've got a Zookeeper JVM flag option here. This is used to set JVM flags that should be included in the Zookeeper JVM process, or the Java process that's used to start Zookeeper when the Zookeeper service fires up Zookeeper. And you can see here that by default, we're going to set the maximum heap size to 1 gigabyte. This can obviously be changed during the playbook run to include additional JVM flags if you're interested in doing so. And then there's two parameters down here at the bottom that are used for cloud deployments. There's a node map, which basically tells the playbook how many nodes and of what type should be created during the playbook run. So we're going to create, by default, a Zookeeper ensemble with 3 nodes. And then a set of application security group rules that are specific to this playbook run. So you can see that in our Zookeeper deployments, by default, we're going to create an application security group rule that opens up port 2888, 3888, and 2181 on the internal subnet. And I'll show you the internal and external subnet momentarily. This first port, 2888, is used for communications between followers and the leader. This second is used between for communications between the nodes for leader election in the Zookeeper ensemble run. And this third one, 2181, is used for client connections to Zookeeper. All of our processes will talk to Zookeeper across the internal subnet for security purposes. So that's the basic variables file that defines the defaults that are typically used in an Ansible playbook run using this provisioned Zookeeper playbook. In addition, during the playbook run, a configuration file is loaded. And if you don't specify the config file during the playbook run, it will actually use this config.yaml as a default. So this is a default configuration file that's used to specify the parameters that we think would typically change from one playbook run to another. You can see that we define a cloud, which is either AWS or OSP. If it's not either AWS or OSP, we're going to assume that the configuration, or that the inventory that's being passed in is being passed in as a static inventory file. But in the case of an AWS or OSP cloud value, if this is defined and it's set to either AWS or OSP, it will use some dynamic inventory scripts or dynamic inventory modules to gather the inventory information for a matching set of nodes in the AWS or OSP environment that's being targeted. Now, what do I mean when I say matching? Well, there's a set of tags here that are used to tag the virtual machines that are created, or to set the tags for the virtual machines we're looking for as target nodes. These 3 tags must be defined, the tenant, project, and domain. And this is kind of from the least specific to the most specific. DataNexus being the tenant, and the project in question being demo in this example, and the domain being production. You can think of the domain as where you'd separate out things like production, development, and test, or dev, prod, and test. These are all free format tags, but you would use them the way you see fit to separate out the various environments that you're creating various clusters and ensembles. In addition to these three, there are two more that are optional. The first one is the cluster tag, and the cluster tag is a single letter, A to Z, and that cluster tag is used to separate out different clusters that you might have created within the same domain, project, and tenant. So, maybe under production I have three different clusters. I label them A, B, and C, or X, Y, and Z, whatever you'd like. In addition, there is a data flow tag that can be used to specify a string that you use to link together all of the clusters that make up a given data flow. So you might call it data pipeline, or maybe just pipeline. And everything in pipeline 1 would get a data flow tag of pipeline 1. And then you'd know that the Zookeeper, Kafka, and Solar instances that have pipeline 1 are all linked together into the same data flow. We'll go into that a little bit more when we show some examples in future videos. That's the tags and the cloud type. In addition, we define some network parameters here. There's a CIDR block that's used to specify essentially the VPC in an AWS environment or OSP environment, the equivalent in the OSP environment, the area or the region and VPC under which you want to create these machines. And in this case, it's the 10.10.0/16. And then in addition to the CIDR block, we define two subnets, the internal and external subnet. These can be set to the same value. The internal subnet could be left out, in which case it will take the same value as the external subnet, and it will be a single network deployment. But typically we separate out the internal and external subnet for security reasons, so that we can secure things on the internal subnet differently than on the external subnet. So in this example, you can see that there's a 10.10.1/0/24 and a 10.10.2.0/24 subnet that are being defined. We also need to define the user name that should be used to access the systems via SSH during the Ansible playbook run. And for AWS, this defaults to CentOS, because that's the username that's used in the images that we typically load. And then there's some AWS specific parameters here. Up until now, these are fairly generic. This is AWS specific. So I'm setting up a US West 2 region. There's an equivalent region tag in OSP with some additional parameters that also need to be defined. And then we define the type of machine that we would like to create in that environment if there's no target nodes that already exist. In this case, by default, we're going to create T2 small nodes. There's also an image parameter here that you can use to specify a specific image. The reason this is commented out by default is that these image names, while fairly easy to use, are specific to a given region. This is a CentOS 7 image within the US West 2 region, but if you switch this region to something else, then you'd have to switch this image tag. So you'll see that in a lot of the future playbook runs that we're going to demonstrate, we actually do set this image. If you don't set an image, then it will search for the appropriate image within your region and use that. But to save a little time, we can actually specify the image once we know what the image ID is. Finally, we've defined a couple of parameters here associated with the data and root volume sizes, the root volume and the data volume. These sizes are in gigabytes, and you can see that by default we create a root volume, or a VM with a root volume of 11 gigs. This is the size of the partition where the operating system is installed, and a data volume of 20 gigs. Again, the data volume does not need to be set, and if it is not set, then the root volume should probably be set larger so that you'll have some space to store the data that's going to be stored on the virtual machine that's being used for the Zookeeper node. So that's the basic configuration file. Hopefully this gives you a feel for what the layout of a typical DataNexus application deployment repository looks like. As I said, in future videos, we'll walk you through actually using this, setting up some custom configuration files, and using those to guide the deployment of a typical, say, Zookeeper ensemble or Kafka cluster. Thank you very much, and we'll talk again soon.